So hey guys, welcome back to another video. Today we will learn about performance anti-patterns. So what are performance anti-patterns? Let me write the topic first. So performance anti-patterns. What are performance anti-patterns? So first let's go with the definition, right? Performance and anti-patterns in a system design refer to common mistakes or suboptimal practices that can lead to poor performance in a system. So, like common practices or common mistakes, like the minor mistakes that we do while creating a system design, which can lead to poor performance in a system, that is known as performance anti-patterns. These patterns can occur at different levels of system and can be caused by a variety of factors such as poor design, lack of optimization, lack of understanding of the workload, right? So, performance anti-patterns basically means if your system is performing poorly with some minor or common mistake that you have made or suboptimal practice, then it's a performance anti-pattern thing, right? Now it can be caused by a variety of factors such as first is what? Poor design. Of course you need an experienced architecture designer. Lack of optimization, this is one thing. What else? Lack of understanding of workload. So if you don't know how much workload will be there, so that can also be one of the reason for poor performance. Okay, so that is one thing. Now what else? Now some of the examples of performance anti-patterns include, first is N+1 queries. What is N+1 queries? Let me explain that. So what is N+1 queries? This occurs when a system makes multiple queries to a database, right, to retrieve related data. Now if you have if you want to, for a user, if you want to fetch DOB, you want to fetch age, you want to fetch what else, hobbies, right? So if you want to fetch all of this for a single user, and if you are querying the DB again and again, so that is N+1 query thing. You should write a single query to retrieve all necessary data. You should write a single query instead of like Q1, Q2, Q3. There should be only one query combined, just Q4, and that query should bring all the data from the server. So that is one thing. You should be aware of N+1 queries. Now second is Chatty Interfaces. What is Chatty Interfaces? Let me explain. So this occurs when a system makes too many small and frequent requests to an external service or API. What it means, that if you have a server, let's suppose this is your server, and this makes let's say it's a weather app, right? It's a weather app, let's suppose. Then if you make too many small requests or frequent requests to an external API, this will of course it will be going with the external API, try to have some request over that API, and that API will respond with correct data of the weather, right? So instead of making fewer larger requests, right? So what you should do, you should have a fewer requests instead of multiple requests to this API, multiple small requests. There should be one request which will gather all the data at once, right? It should be one huge request, right? Whatever. So it can gather all that, and then you can save it in what cache or somewhere in DB, in your internal DB, right? That will also improve your performance. Now third is unbounded data. What is unbounded data? Now this occurs when a system retrieves or processes more data than is necessary for the task at hand, leading to increased resource usage and reduced performance. Now in this case, what we can use here, we can use GraphQL, the example that we saw earlier, right? It all only brings the required data, right? We want unbounded data, means the data which is unbounded, which is unused, right? So if we bring that data from the server which is unused, that will cause increased resource usage and reduced performance, right? If resource will be used more for unnecessary data, of course other allocating to other resource or other background services, it will be relatively difficult. Okay, so what we can use GraphQL for. Now what else is inefficient algorithms? Of course, what is inefficient algorithms? Now this occurs when a system uses an algorithm that is not well suited to the task at hand, leading to increased resource usage and reduced performance. Of course, when you are writing an algorithm, make sure that it's optimized. Try to optimize it as much as possible. Try to optimize it till log n, right? Or n, not more than not less than that, not more than that actually, right? N square on n cube, that's the bad algorithm, right? That's a brute force approach. So don't try to go with it. Try to use some algorithms which are efficient. Try to use AI, try to use ChatGPT, or try to use help from your own experience, right? How to optimize an algorithm. That will, of course, increase your performance, because that will make sure that not more threads are involved in your algorithm while running that algorithm, right? Now performance anti-patterns are done. Now let's learn about improper instantiation. What is improper? So we have in performance anti-patterns, we have learned what is performance anti-pattern and what are the causes: poor design, lack of optimization, workload, lack of understanding of the workload. What are its what are the examples of it? First is the N+1 queries. So you should be aware of how you should write queries. There shouldn't be multiple queries for a single. If you want to retrieve a single entry, then there should be a combination of, there should be bundle of all the related stuff that you want to query in a single query. Chatty interface, of course, there shouldn't be multiple requests to an external API. One single user request is enough. Unbounded data, there shouldn't be unused data, because that will cause usage of more resource and more memory. Inefficient algorithm will also cause insufficient usage. It will cause more usage of your performance and RAM and other resources. So that's all. Now let's learn about improper instantiation. Right? Improper instantiation. What is improper instantiation? So improper instantiation in system design refers to the practice of creating unnecessary instances of an object. What is unnecessary instance of an object, right? If you have learned about OOPS concept, you might know what I'm talking about. If you haven't, please go and check out other videos. Clear your OOPS concept. So creating unnecessary instances of object, class or service which can lead to performance and scalability issues. So make sure you have proper instantiation. If you aren't using any class or object, make sure to remove that instance of class and object or any service, right? Don't deploy it, right? This can happen when the system is not properly designed, when the code is not written in an efficient way. When you are writing code, you should follow these practices of a book known as Clean Code. So make sure to follow that book. Actually, there are like very good concept how you should be writing clean code, how unit tests should be written, how solid principles are implemented. There are actually many other topics. Let me show you Clean Code book I have actually. So clean code topics. Let me write what topics are there. See. Meaningful naming. So the naming of the functions or variables or classes should be meaningful. It should be descriptive. It should be defining what function is doing, right? If you want to add two numbers, right? So what will you name the function? Add two num, right? Something like that. If you want to add n number of variables, then you can write add numbers. That should be a function or a variable class name, right? Function single responsibility principle SRP. One function should have only one responsibility. It shouldn't be doing multiple things, because that will make it confusing. Comments should be purposeful and self-explanatory. Formatting and structure, consistent style, vertical density and all. Objects and data structure. So these are error handling. How you should be writing unit test, writing comprehensive unit to ensure code correctness and facilitate. You can use jest or other solid principles as I was saying, and dry. Don't repeat yourself. Avoid repeating or duplicating the code through abstraction and reuse, right? Of course, if you are writing any function which has the same logic, which has been repeated over multiple classes or multiple modules, then try to make it in a single module, try to import it and try to use it. Okay, so that can be one thing. Guess what is keep it simple, stupid, right? Prioritizing simplicity, avoiding unnecessary complexity. Of course, simplicity doesn't mean that you shouldn't be optimizing your algorithm. Of course, you should optimize it, but try to make the logic simpler so that other developers that read, it should be easier for them, right? Refactoring, continuous improvement, regularly refactoring code to improve its structure, readability. So make sure to have this practice. It is very important. Even if you have improved code base, try to improve it more. Try to improve it using new libraries in Node.js or new versions of Node.js or whatever, right? Version control effective use, utilizing version control system to manage. Of course, this is talking about Git. So that was about it. You can use clean code principles for this writing code. Now that was about improper instantiation, right? You should not have unnecessary instances of object, class, or service, because that can lead to performance and scalability issue. Now, what is monolithic persistence? Read the topic. Monolithic persistence. What is this? Monolithic persistence refers to the use of a single monolithic database to store all of the data for an application or system. See, monolithic, monolithic architecture, right? Having everything in a single service. Now, what is monolithic persistence? It is about if you are having monolithic persistence, refer to a single monolithic database to store all the data for an application or system. So we will be having only a single database to store everything, image, let's suppose image, documents or fields or entries or JSON, everything in a single database. So we will be storing everything in a single DB. Single DB means it can be SQL or whatever, right? We won't be using polyglot approach, right? So this approach can be used for small scale systems, but as the system grows, evolves, it can become a bottleneck, resulting in poor scalability, limited flexibility, and increased complexity. Because we are using single DB, what it means that scalability would be a huge issue here, and it can be good for a small scale system, right? If you are creating a website, a normal website which doesn't involve any user interaction, it's just a scroll and some animations, then of course you can go with a single database. But if website is complex, there is backend, there is front end, there are some other services involved like microservices, then we should go with polyglot approach, where we can use multiple DB for different requirements. And now, of course, using a single DB, it will be not that much flexible, and complexity will be increased, and so on, right? To address this limitation, a number of approaches can be taken. You can use microservices, of course, as I told. You can use sharding. You can divide this single database into multiple, depending on the row or column wise, and NoSQL databases, right? You can also use NoSQL database. So that is also one thing, MongoDB or something like that. Now let's learn about noisy neighbor. What is noisy neighbor? Let me just write the first topic. Noisy neighbor, right? What is noisy neighbor? Noisy neighbor refers to a situation in which one or more components of a system are utilizing a disproportionate amount of shared resources, leading to resource contention and reduced performance for other components. Now what happens? Noisy neighbor means, as it says, right? Noisy neighbor. So your neighbor is very noisy. So what it means, whenever you have a component or a service that is utilizing too much resources than it should, using shared resources, it can lead to what? It can lead to resource contention and reduce performance for other components. Of course, other components won't be able to utilize much of the resources, right? If you have 3 GB of RAM, let's suppose, if you have a 3 GB of RAM, this is a service S1, which is utilizing approx 2 GB, and other resources S2, S3, or whatever background services that we have. This was also required 1 and 1 GB of RAM, right? This would have required 0.5 and 0.5 GB of RAM, but this service is utilizing 2 GB, so this will utilize remaining 1 GB, and this won't be utilizing anything. This service will be just utilizing 0.1 or 0.1 something, because everything, the whole RAM has been utilized by S1 only. So that is one thing. This can occur when a system is not properly designed or configured to handle workload, and when component is behaving unexpectedly, right? So this can happen in that situations. Now examples of noisy neighbor. What are examples of noisy neighbor? Let me just write here. Example of noisy neighbors are one user on a shared server utilizing a large amount of CPU or memory, leading to reduced performance. Let's suppose there is a shared CPU, or you are using cloud CPU, and one user is playing a game, let's suppose GTA 5. So it will be utilizing a more CPU usage, right? So because of what, other users won't be able to utilize your CPU or memory. It can reduce their performance, right? Even for a single, if they want to open a Word file, or if they want to open Excel, right? They won't be able to do it because a single user is using everything, every whatever resources that CPU had, like memory, RAM, and other things, right? GPU and all. So that is one example that if a single user is using too much resource, single user using large amount of CPU usage. This can be GPU as well, whatever. Okay. Second example can be one process on a shared server utilizing a large amount of input output, causing other processes to experience slow input output and increasing latency. And now this can also be related to process, as I said. These were the services. These were the actually background jobs or background processes. You can say it, background task. Okay, whatever. So process, it can the same ideology can be applied to process. If your process is running on background and it is utilizing server resources in a large amount for input output operation, it can cause other process to slow down, right? Other processes will slow down. This process is fast. This single process will run faster, but the other process will of course slow down. Now what is third? Third is one application consuming a large number of network bandwidth, causing other application to experience reduced throughput. Throughput, we have already learned about what is throughput. In a single period of time, how many requests application or server can serve. That is what throughput is, right? If one application is consuming large amount of network bandwidth, let's suppose one application consuming large amount of bandwidth. Okay. So what it can result in is causing others to reduce throughput. Okay. Other applications, not others, right? Other applications to face reduced throughput, right? So that can be one example of noisy neighbor. What is noisy neighbor? We have already learned about it. So noisy neighbor refers to, let me rephrase this. Noisy neighbor refers to what? If a single process is taking too much resources, then it should and performance other resources to other application, process, or user to significantly reduce their usage, or they aren't able to run the process as it should be, then it is known as noisy neighbor. How you can what are the causes of it? The causes are if you are unable to configure or handle the workload, if your system is not properly designed, if the components that you have established are behaving unexpectedly, that can be the reasons. Now what were the examples? Single user using large amount of CPU usage or GPU usage, right? The performance for other users on the same server will reduce, right? Second example was one process over a shared server utilizing a large amount of IO, input output, which can cause other process to experience slow IO and increase latency. Other process will have increased latency, right? Third example was about one application consuming a large amount of network bandwidth, causing other application to experience reduced throughput, right? If single application is using too much Wi-Fi or too much bandwidth for the Wi-Fi, let's suppose your Wi-Fi is giving you 3 Mbps of speed and 2 Mbps is just for that application, right? If you are downloading uTorrent, if you are downloading any movie on uTorrent, what happens? 1 and 2.2 Mbps got consumed by that single application, and then when you try to run Netflix, it will perform very slowly because the bandwidth has been utilized by your uTorrent, right? So that can be an example of this uTorrent and Netflix. Let me just write uTorrent, and this is the example that I have actually faced in real life. Okay, so Netflix doesn't work in the way it should be working, so that is one thing. Now let's suppose after this, what else? Synchronous IO, synchronous input output. What is blocking the calling thread while IO completes can reduce performance and affect vertical scalability.